In the vast tapestry of nature, tiny actions can echo into the future. A butterfly flutters its delicate wings, and somewhere days or miles away, a storm may gather strength. This is the essence of the butterfly effects, the idea that small changes in the starting state of a system can lead to vastly different outcomes, making the future notoriously hard to predict. In chaos theory, this poetic notion is more than metaphor. It was born in the early 1960s, when a meteorologist named Edward N. Lorenz stumbled upon a startling discovery. The weather system around us is deterministic, governed by equations, yet even the tiniest tweak can unleash a cascade of consequences. Edward Lorenz, a mathematician turned meteorologist at MIT, was fascinated by weather. He built a mathematical model with a handful of differential equations to simulate the atmosphere. By 1961, Lorenz has a primitive computer churning out a day's simulated weather each minute. One winter morning, Lorenz wanted to review a particular sequence of weather data without rerunning the entire program. He paused the simulation, typed the output number by hand, and then stepped away for a cup of coffee. When he returned an hour later, he found something astonishing. The new simulation had diverged dramatically from the original, even though he thought he'd given it the same starting conditions. Within a few simulated months, the two weather patterns had nothing in common. At first, Lorenz feared a hardware glitch. Instead, the culprit was insidious. Rounding, the computer stored each variable to 6 decimal places, but the printout showed only 3. Lorenz had entered the initial value 0.506 instead of 0.506127. That 1000 difference, a flicker so small it seemed inconsequential, triggered a completely different forecast. In most physical systems, tiny errors hardly matter. A puff of wind won't normally ruin an entire forecast, or so Lorenz assumed. But in his simple weather model, sensitive dependence on initial conditions ruled. Small discrepancies mushroomed exponentially, illustrating that in some systems, a small change in initial conditions can produce a great change in the final outcome. Out of this discovery, Lorenz coined a now famous image. The flapping of a butterfly's wings in Brazil could set off a tornado in Texas. The humble butterfly became a symbol, not because a literal insect causes distant storms, but because our complex world is so exquisitely sensitive. Lorenz himself presented this metaphor during a 1972 scientific meeting, questioning whether such a tiny flutter might one day culminate in a tornado. This butterfly effect lays the groundwork for chaos theory, revealing that even entirely deterministic equations can produce behavior that seems random and unpredictable. Lorenz's insight upended earlier ideals of perfect predictability, showing that long-range forecasting is fundamentally limited by nature itself. Curious follow-up work led Lorenz to the Lorenz attractor, a beautiful chaotic trajectory of just 3 equations instead of settling to a steady state. It traced a never-repeating double spiral resembling a butterfly's wings. Each loop of the attractor represents how 2 nearly identical weather states diverge widely over time, while still bounded in the atmosphere. Analogies and real-world ripples. Science fiction has long played with this idea. In Ray Bradbury's A Sound of Thunder, a time traveler accidentally crushes a butterfly during a dinosaur hunt. Returning to his own time, he finds the world altered in subtle yet profound ways. History has shifted on the flap of a wing. Even today, people tell personal butterfly stories. A flat tire might lead you to miss one train and miss meeting a stranger. A last-minute decision to stay home could mean never finding your future spouse. One online thread collected anecdotes, a broken shoe, a missed flight, a lost pet, each a small twist credited for changing someone's life path. These tales capture our fascination, but experts note they often reflect coincidence more than strict chaos. A world of unpredictability. The butterfly effect at its heart, a humbling reminder. It tells us that in a complex world, certainty has limits. Even with perfect science, the future remains veiled. As one scientist put it, the effect disrupted science at a philosophical level, showing that chaos is always present, if hard to discern. So what does this mean for us? Perhaps that every small choice matters, even when we can't see how. Each decision, each flutter of intention sends ripples through time. As the camera pulls back from the butterfly to reveal the entire Earth bathed in morning light, we consider in a universe of infinite possibilities. Our world is shaped by the grand and the minute, by hurricanes and by butterfly wings. Thank you for watching. See you next time.